So in this revision video today, what we're going to be looking at is two different types of distillation. We're going to start off with our simple distillation setup, and we are going to be doing some distillation of brine, which is just sodium chloride dissolved in water. So that's our first setup. And then after that one, we're going to be looking at fractional distillation, which is just set up behind you, and we're going to be looking at the differences between the two of them. Okay, so this is our simple distillation setup. We've got our standard Bunsen burner to heat it, we've got a tripod and a gauze, we've got a conical flask with a delivery tube, which is coming down to a boiling tube here, which is actually in some ice water, and we're going to be looking at what that does in a minute. And to keep it secure, we've just got a clamp stand holding it in place on top of the tripod. So we're going to add some of our brine solution into the conical flask to get us started, and then we're going to light the Bunsen burner. So just going to put a small amount in there, otherwise we'll be here all day, and we will get our Bunsen burner lit in a second. So now I am just replacing the bung into the top of the conical flask nice and securely, and this is there so that as the liquid boils away, it all passes into the delivery tube instead of being lost out of the top of the conical flask, because we want all of it into the boiling tube at the end. Right, so we're going to get our Bunsen burner lit, making sure, as always, we are initially lighting our Bunsen burner on the safety flame. So our safety flame that we can see, the bright orange, and then I'm going to turn it onto the roaring flame by opening the hole on the Bunsen burner, and I'm going to get that under our tripod, and we're going to give it a few minutes and watch what happens in our conical flask. Now, after a couple of minutes, our solution is starting to bubble as the liquid water boils and becomes water vapour. So you can see some steam rising off the surface of the solution there, and it's all passing into the delivery tube, heading towards our boiling tube, where it will cool down and condense. Here's a nice close-up shot of the boiling tube in the ice water, and you can see the level of the water rising in the boiling tube as the water vapour has passed into it and cooled and condensed, turning it from a vapour back to a liquid. Now, after we've left this solution boiling for a while, you can see there is no liquid left in the conical flask anymore, so it is time to turn off the Bunsen burner and have a little look at what is left. So this white solid coating all over the inside of the conical flask is our salt that has been left behind as all of the water has boiled away, leaving our dissolved solid in the conical flask. Now let's take a look in our boiling tube, and as you can see, all of our water vapour has condensed back into liquid water in the tube due to the cold ice around it. Now this here is pure water. It should have no dissolved solids in it, as they should have all remained in the conical flask. So that is something to consider if you are thinking about potable versus pure water. This is pure water with no dissolved solids in it, rather than potable water, which just means it is safe to drink. Now let's look at some exam questions about distillation. So this diagram here shows the simple distillation setup that we saw in our video, and they're using this to distill seawater. This is basically the same as what we were doing with the brine solution, or they could refer to it as a sodium chloride solution, a salt solution, or salt water. It's all the same process that they are talking about. So simple distillation often comes up as part of the Earth's resources topic, as it's linked to purifying drinking water. There's an entire required practical based around distilling different types of water, such as river water or rainwater, but we're not going to go into detail about that now. So let's look at the question in hand. A student distilled a sample of seawater in the apparatus shown below. What change of state is happening at the surface of the seawater? So the seawater is in the conical flask. So as we saw earlier, it's being heated by the Bunsen burner, and that is where our water is boiling, which is the change of state from a liquid to a gas or a vapour, as we were calling it earlier. The change of state, if you were asked about the test tube, is condensing where that water is cooling and doing the opposite and going from a gas back to a liquid. So question number 2, describe how the water in the test tube is different from the seawater. So our seawater has lots of dissolved solids in it, so that's our salt, and this is left behind when the water boils because the boiling point of the salt is so much higher than the water, so the water boils away and that leaves the salt behind. So therefore, the water that collects in the test tube is pure water that has no salt present, as all of that salt remains in the conical flask, which is what we could see as that white coating on the inside of the conical flask. Our final one then, why does producing drinking water from seawater using distillation cost a lot of money? So this is a kind of real world application for this question, and the Earth Resources Unit often looks at the economical impact of chemical processes, and this process of distillation, also known as desalination, is something that is often asked about. So for this whole process, we need to heat the water to its boiling point in order for distillation to work. That's not difficult to do for small amounts of water, but it becomes extremely expensive when it's done on a large scale because lots of energy is required to boil large quantities of water. So if a country is looking to get more drinking water, perhaps if they have a shortage and they are a coastal area, they may look into desalination, and this is done in some parts of the world, but it's not that common just because of the cost and the energy implications. So now we've covered simple distillation, it's time to look at fractional distillation. So over here now I've got our second setup, so this is fractional distillation rather than simple distillation. And as you can see, it's got a little bit more equipment this time. We have this extra, what we call a fractionating column that is here to separate the mixture that we've got this time. So our previous simple distillation was for separating solutions, so a solute dissolved in a solvent, whereas this one, for fractional distillation, we use this to separate mixtures of liquids with different boiling points. So what I've got in my beaker here is a mixture of ethanol and water, and I'm going to talk you through this process and how this is a little bit different from simple distillation, and we can separate the ethanol and hopefully be able to ignite the ethanol on its own at the end. So our equipment setup here is a little bit more complex, things that you're probably not used to using in a science lab. We've got a round bottom flask here resting on top of our usual tripod and gauze and Bunsen burner. We've got our fractionating column, which I'll show you a close-up of in a second, with some little glass nodules that help with the separation technique. We've got a funnel at the top just so I can pour my solution in a second, and then once I've done that I'll be replacing it with a thermometer so we can check when we are actually boiling off the ethanol. We've got our condenser here, which is connected up to the tap so that we get a flow of cold water through the condenser at all times. So it's coming in through this tube, and it's kind of like a glass jacket, like a double layer with the cold water in it, and then it comes out of this side and drains into the sink. And then we have a little dish here with some cotton wool in that is going to collect our ethanol at the end and make it a little bit easier for us to ignite. And it's all just held securely in place with some clamp stands. Now we can take a closer look at the fractionating column itself, just as I am adding my mixture of ethanol and water. So you can see it's this long glass column with sort of small spikes of glass pointing to the inside of the column, and we'll look at what they do shortly. So there's plenty of the mixture now into the round bottom flask at the bottom, ready to distill. Here as well is a close-up of the condenser. Now you can see there the two tubes labelled in and out, so this is where our water comes in, so that's our cold water directly from the tap that will be used to cool and condense our vapour. This setup could actually be used to distill the solution we were looking at earlier. You just would not include the fractionating column, but you could use this condenser instead of the ice water that we were looking at. So we're going to light the Bunsen burner now underneath our fractionating column. I've made sure any of my leftover ethanol has been moved well out of the way, as it is extremely flammable. Again, I'm going to light my Bunsen burner using the safety flame and then get it onto not quite a roaring flame this time, probably sort of a mid flame. You might not pick that up on the camera, but it's kind of halfway between a roaring flame and a safety flame. And the reason I'm doing this is because with this particular equipment, if I heat it too strongly, I can end up getting some boil over, and I can end up with all of the water passing through the system, and that would then contaminate our sample at the end. So I'm just going to leave it running on a slightly less powerful flame this time, and we'll see what happens through the process. After a couple of minutes, our water and ethanol mixture has begun to boil in the round bottom flask. Now, even though ethanol has a lower boiling point than water, there will be some of both liquids boiling at this point. However, only the ethanol will make it into the condenser and then be collected at the end. And this is thanks to the fractionating column, which we're going to take a closer look at in a second. Now, if we take a little closer look at our fractionating column, we can see why the water will remain in the round bottom flask for longer. So I've slowed it down a little bit so you can see the drips of liquid water inside the fractionating column. And the reason why the water is condensing from a gas back to a liquid is due to the little glass nodules, or the sort of spikes that you can see. So these glass nodules are actually colder than the boiling point of water, so they are at below 100 degrees C. So when the water vapour touches the little glass nodules, it can cool and condense back into liquid water and drip back into the round bottom flask. Now this process will continue to happen, this boiling, condensing, until the temperature of the glass nodules is above 100 degrees, and then the water can remain as a vapour and pass into the condenser to be collected at the end, hopefully a long time after all of the ethanol has boiled and been condensed and collected. Here on a close-up of the condenser, we can see that the ethanol is cooling from the water from the tap and turning from a gas back into a liquid. So it's condensing, which allows the liquid ethanol to run through the condenser and then drip out at the end to be collected in a small dish beneath. So we've got our sample of ethanol that has been distilled from our mixture of water and ethanol, and with any luck I should be able to ignite the ethanol that I've got in here. I've got a splint and I'm standing well back, and it should catch. Now, unfortunately, the flame from ethanol is very difficult to see. There's sort of a light blue flame. It is burning, but it is probably quite hard to see on the camera. There is a light blue flame. With the lights off, it's much easier to see the flame on our ethanol, so we can see it burning here, and we have successfully distilled ethanol from a mixture of ethanol and water due to the lower boiling point of ethanol. Just to finish up, let's take a look at how this second setup can look in diagrams in exams. So this first diagram here is showing simple distillation using the condenser, and you can see that it's very similar to what we were just doing, apart from the fractionating column is absent. So this uses the same concept as we did with our simple distillation using the ice water, except the cooling to cause the water vapour to condense is happening inside the condenser, and then it is dripping out at the end, rather than the steam making its way as far as the beaker at the end and then being cooled by ice within the beaker. Now let's have a look at how the fractional distillation setup would appear in a diagram. So this is the same setup as what we've just shown in the video, apart from the fractionating column is packed with glass beads rather than the small glass nodules or spikes we were looking at. It's exactly the same concept. Those glass beads will be at a temperature lower than the boiling point of the liquid with the higher boiling point, so that the liquid with the lower boiling point remains a vapour as it passes through the column and into the condenser, whereas the liquid with the higher boiling point will cool and condense on those glass beads and drip back into the round bottom flask. Now this is the setup that is used to separate solutions with two different boiling points, so that's why we used it for our ethanol and water, whereas this setup would be used to separate a solution of a solid solute dissolved in a liquid. I hope this video has been useful for you and that it has cleared up the differences between fractional distillation and simple distillation. Thanks for watching.